So we have studied about the modeling, different types of modeling in the previous lecture. So we have studied about the three different types of model. They are these are the theoretical model, empirical model, and semi-empirical model. We also have covered what do you understand by the theoretical model, then empirical model and semi-empirical model, right? So today, okay, we have also seen what are the different tools used in order to find out the model in the theoretical modeling. So generally we are using the principle of conservation, and in the principle of conservation, total mass, energy, momentum, and the component balance are used, right, for the identification of the model. So how the mass conservation, component balance, energy balance has been written. The simple fundamental is the in minus out is equals to accumulation, right? Whatever the heat generated, whatever some generation and whatever some absorption, based on the principle like the mass, energy, they will be applied, right? We have also seen the different types of the equation come under the when you are going to develop the model, such as when you are going to develop the model using the lumped parametric model, okay, and the steady state, then algebraic equation will come. However, when the lumped type of the model with unsteady state are using, then ODE will generated. However, when the distributed parametric model are there, distributed parametric model and unsteady state model is there, then the PDE will come in the picture, right? So these we have already discussed, right? Okay. Then we have discussed about the linear and nonlinear model. We will see the example of the linear and nonlinear model today also. And these are the different types of the variation in the model we have covered. Okay, we also have seen the what is the difference between regulator and servo problem. In the servo problem, we are focused on the tracking. Okay, however, the load is constant. In the regulator problem, the load is varying. However, the set point is constant. These are the fundamental of the transfer function we already have covered, right? Or we have developed the model for the operation amplifier as well as the mass damper problem. And then today we are going to have a model of the tank system. Okay, this is one of the fundamental and basic model used in the chemical process industries, right? Any process industries. So how this model is going to develop is a first fundamental model. So please be careful in order to develop this model. Okay, so how this model is going to develop, please see. So here in this tank you can see here some fluid is coming from, some fluid is entering in the tank with the flow rate QT, and QT is the volumetric flow rate. Remember, it is the volumetric flow rate. Volumetric flow rate means the whatever the volume is coming, the unit for the volume is generally meter cube. Okay, meter cube per second, or you can say the volume per unit time. Okay, volumetric flow rate. Flow rate is coming with the volume. Okay, with respect to the time. The same Q naught T is the outlet flow rate, or you can say outlet the product flow rate. Okay, leaving from the product side. Okay, and R is the resistance offered by the valve. It may be the linear, it may be the non-linear, right? It may be the linear or non-linear, depends on the characteristic of the valve. In this example, we have taken the linear valve. First, we have focusing into the linear valve, then we will see the non-linear valve also. Okay, so the fundamental is how the model is going to develop. So we have to control the height or the level of the tank. We have to maintain the level. We have to control the level of this flow. So we have to maintain this HT. So in order to HT, this is the accumulation. This is the mass entering into the tank. Whatever the flow, whatever the fluid is coming, this is the mass. And this mass is going to hold up, or you can say the accumulated inside the tank. Okay, in form of the HT. Because as HT will change, height will change. Okay, with the time. So this is the hold up. Right. So mass means, what is the mass? How the mass will be calculated? So you know density. What is the formula for the density? Density is equals to density is equals to
Mass
density is equals to
upon
mass upon
volume.
volume. Yes, density is equals to mass upon volume. Right. So when you multiply, you know what is entering? Entering is the mass, because we have to balance the mass. हम लोग को क्या बैलेंस करना है? मास बैलेंस करना है. तो वाट एवर द मास इज कमिंग equal to the mass hold up plus mass leaving. Yes or no? Yes or no? Mass entering is equals to the mass leaving plus mass accumulation. Yes? हाँ जी जी जी. हाँ जी 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 सर. सर एक्चुअली एक मिनट में सर, मैं आपको एक मिनट में क्लास ले रहा था. वेट वेट मिनट सर, वेट मिनट. यस सर, उनके आंख में ना सर रह रहे कि प्रेशर बढ़ जाता है. तो प्रेशर बढ़ जाता है, तो उसमें ना आंख में मैंने सर दिखाया भी है, तो टीबी का उन्होंने चेकअप वगैरह कराया था, उसमें कुछ आया नहीं है ना. और उसमें उनको कभी कभी कुछ एक ग्लूकोमा का अटैक भी एक दो बार आ चुका है, मतलब एज पर द डॉक्टर है ना. लेकिन सर उसमें होता क्या कि कुछ जब तक चेक कराए, एमआरआई वगैरह भी कराए, उसमें कुछ निकला नहीं है ना. ना टीबी निकला, ना कुछ निकला है. ठीक है. तो उसमें होता क्या कि उनका आंख में तो कभी कभी जब मौसम चेंज होता है, जैसे अब गर्मी से ठंडा होगा या ठंडा से जब मौसम चेंज होगा, गर्मी आएगी, उस समय उनके आंख के ऊपर पूरा भारीपन लगता है और कभी कभी बहुत ज्यादा दर्द होता है. तो जिससे वो आ, सर प्रेशर मुझे पूछना पड़ेगा वाइफ से. अभी तो वो घर पर है, मैं ऑफिस में आया हूँ. सर ये होता है लगभग लगभग, मान के चलो आपकी साल में 3 4 5 बार तो हो ही जाता है, 6 बार. और इस समय रेगुलरली हो रहा है. हम्म हम्म हम्म. तो अभी क्या करेंगे सर? अच्छा 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 अच्छा. ठीक है ठीक है ठीक है ठीक है सर. ओके, थैंक यू. Okay, sorry for the interruption. Now my voice is audible. Okay.
Yes, sir.
तो हम लोग थे कि मास इंटर हो रहा है, तो मास वाट एवर द मास इज इंटरिंग इज इक्वल टू द मास एक्यूमुलेटेड प्लस मास लीविंग. यस और नो? So on that fundamental, we have just calculated the mass. And what is the mass? Density into the volumetric flow rate. So mass क्या है? मास जो इंटर कर रहा है विद द रिस्पेक्ट ऑफ द टाइम, केजी पर सेकेंड. यस और नो? केजी पर सेकेंड इज इंटरिंग, kg per second is in the accumulation, and plus kg per second is in the living term. Right. So we have to balance, we have to equate this equation. In minus in is equals to accumulated plus output. Is it clear?
Yes, sir.
So this is the mass with respect to the time. So density is equals to, you have told me, kg mass upon volume. Density is equals to mass upon volume. And what is the volumetric flow rate? I already told you, meter cube per second. Meter cube per second. So it will give the kg per second. Yes or no? It will give the kg per second. This is the mass. It becomes ultimately mass. Mass per second. Okay, right? Yes or no?
Yes, sir.
So whatever the mass is entering minus mass out, Similarly, you can say calculate the density because the density remains same of the fluid. The density of the fluid remain constant. Okay, so entering at the entering side, at the hold up and at the leaving side, the densities remain constant, right? So density into the product flow rate is equal is you know is the this term, right? यहाँ तक हो गया in minus out is equals to in minus out is equals to please in minus out is equals to
Accumulation.
accumulation. And what is the accumulation? Accumulation is in the terms of the height. HT is bearing. Yes or no? Or this is simply I will told you this is also written in the term of the mass kg per second, right? So density is density is equals to already told you the kg per meter cube, right? Density equals to mass upon volume. If you multiply the area, then it becomes meter square. Sorry, meter square area. And when you multiply with the height, then it becomes kg per meter cube into meter square into meter. So it will come kg. But you also need, since it is the accumulation, so we have to multiply the d by dt because it is changing with the time. It is changing with the time, right? Accumulation or whatever the accumulation is always written in the terms of differential form, right? So d by dt. So it is 1 by second. So ultimately it becomes kg per second, right? So you have to remember the point to be remembered as the density, the mass whatever is coming, right? The mass whatever the coming is written in the form of rho q. Okay, when the volumetric flow rate is there. If the volumetric flow is not there, then you have to change accordingly, right? But the fundamental remains same. So rho qt minus rho q naught t is equals to d by dt of rho ah. This is the first equation. Okay, since the density is a constant, you can take the constant and you can take the cancel. Okay, so becomes the equation becomes qt minus q naught t is equals to adh by dt. This is very very important. Qt minus q naught t is equals to adh by dt. Remember, adh by dt. Okay, now come to this part. That is the living part. I already told you this is the valve, right? And the valve, this is the resistance. Valve produces, or valve you can say used here as a resistance. It produces some resistance. Okay, it actually this is for the control of the flow, right? Control of that flow. Okay, so this is the relation between the q naught and the h and r, because ultimately this r is going to change the height and this flow. So the relationship between the QHR is equals to Q naught is equals to H by R when the R is a linear. When the R is a linear flow. This is a linear flow. Remember. So when the valve is a linear, then you have to take the Q naught is equals to H by R. It means if the resistance is increasing, means you are going to close the valve, then flow rate will automatically decrease. Yes or no? Yes or no? If the
Yes.
resistance is going to increase, then automatically the flow rate is going to reduce. This Q naught. Or you can say if the resistance is going to decrease, then Q naught will flow. The Q naught will increase. So based on this principle, we have written the Q naught is equals to H by R. This is the equation.
Sir, I am waiting for mail.
बस class में. Q naught is equals to H by R. Right. Now, so put this value Q naught is equals to H by R in this equation, in the original equation. It becomes now Qt minus H by R equal to AdH by dt. Right? Q minus H by R is equals to AdH by dt. Okay? Is it any problem to this equation number 3? If you have, you will ask. No? Okay. So this is the term generally written here because the flow is in the industry. There's a two types of the flow. है ना? If the flow rate is very high, it means the Reynolds number if they greater than 4000. That is the turbulent flow. You can say the turbulent flow. Generally, we are taking in the industry the laminar flow, right? Laminar range. That is the R is equals to 1800 to 2100. Okay. So this is a simple Reynolds number. Right? Okay. Now come to the next part that is very important. Okay, Q. So our equation becomes Q minus H by R is equals to AdH by dt. Now at the steady state. At the steady state क्या होगा? What will the equation? Okay. So this flow, that whatever the Q is coming after a long time, after a long time, all the terms become constant. That is the Q becomes QS. Steady state, it takes the steady state value. Okay, the height becomes constant HS. It will becomes constant. आप ऐसे समझे एक किसी बकेट में आप यहाँ पर होल कर दें और यहाँ से कोई फ्लो रेट आ रहा है तो आफ्टर शुरुआत में ये वेरिएशन H होगा लेकिन आफ्टर लॉन्ग टाइम इट विल सेटल्ड और यहाँ से एक कांस्टेंट फ्लो रेट आउट चलता जाएगा यहाँ से आपका एक क्यूटी आएगा और यहाँ पर एक कांस्टेंट होल्ड अप होकर हो जाएगा इट मीन देयर इज नो डी बाई डी टी एक्यूमुलेशन बिकम्स कांस्टेंट सो इफ द एक्यूमुलेशन बिकम्स कांस्टेंट व्हाट डू मीन द डी बाई डी टी ऑफ एच टी बिकम्स कांस्टेंट सो इट का क्या मतलब है कांस्टेंट का डिफरेंशिएशन क्या होगा एच टी बिकम्स कांस्टेंट व्हाट इज द जीरो यस और नो यस और नो
Yes,
so
sir.
accumulation term at the steady state become zero remember so that's why I have written qs minus hs by r equal to 0 qs it becomes qs it becomes hs by r and this term since it is in the steady state and therefore the it becomes the height becomes constant and differential of the constant becomes 0 and therefore we have written qs minus hs by r is equal to 0. This is equation number 4. Any problem up to the question number 4? You may ask, you are free. If not, I will proceed. Okay, so 3 minus 4 कीजिए. Just subtract question number 3 to minus 4. Subtracting question number 4 to question number 3. What will you got? You got q minus qs h by r minus hs by r q minus qs h minus hs by r प्लस ठीक है जी प्लस क्या हो जाएगा ए डी बाई डी टी ऑफ एच माइनस ये है क्या ये है ए डी बाई डी टी ऑफ एच एस हालांकि ये जीरो है लेकिन ये टर्म तो यही है ना या सुनो भाई जीरो है क्या जीरो इज द ए डी बाई डी टी ऑफ एच एस सिंस इट इज अ कांस्टेंट देयरफॉर इट इज जीरो but this is the equation right and therefore we have written a d by dt h minus hs. Is it clear?
Yes, sir.
Any doubt? Any doubt you have asked?
सर यस सर बट अगर सर एच एस सर कांस्टेंट वैल्यू हो जाएगी सर तो इसका डिफरेंशिएशन ऑलवेज जीरो होगा सर लिखना जरूरी है सर यहाँ एच एस यहाँ लास्ट में आपने जो लिखा
hs लिखना जरूरी है ये वाला कह रहे हो
यही सर यही जो अभी
it is
हाँ
actually
इसके सर
we are
5
actually we are representing at the steady state right we are representing the equation in the terms of the deviation variable में लिखने के लिए हम लोग just hs यूज कर रहे हैं. You are right, it is a zero. But what is this zero? Zero is nothing but the a by d. By technical term तो इसका यही है ना a d by dt of hs. Since this is a constant term, hs is a constant term and therefore it becomes a zero. It is okay. But can we
Yes,
write this
yes.
equation like this one? You are not. We can write now. And there it is basically this is h minus h is a deviation. And therefore we are defining the new term deviation and finally we are trying to write the equation in the term of the transfer function, right? We are trying to find out the model and in order to find out that model we have to write this equation like this, right? Okay,
ओके सर
so now defining the deviation variable q minus qs is equals to capital Q and h minus hs is equals to capital H, right? So simply it becomes q capital qs it becomes hs by r a into d by dt of h a into d by dt of hs and you know the difference Laplace transform of this one What is the Laplace transform of d by dt of Hs? S into Hs? Yes or no? S into Hs, and
Yes, sir. Yes, sir.
you are assuming that initial condition 0 because you are going to find out the ultimate the transfer function. Okay. Okay. So just take Hs as a common. So what is your output? What is your output? Output is your height. What is the input? Input is your flow rate, whatever the entry. Okay. So output is Hs, input is Qs. So Hs upon Qs, just you can write the equation R divided by tau s plus 1, where tau is equals to AR. Just to solve the equation. Okay, it becomes R upon tau s plus 1, where tau is equals to AR. So this is the first order differential equation. It means if you have a tank, simple tank, you have to control the level of the system, then the transfer function of that system is like this one, R upon tau s plus 1 is the standard equation, the standard transfer equation. Okay, R upon tau s plus 1. Is it clear? This is for the linear valve. If you have any doubt, you may ask. Otherwise, I will proceed. Okay? Can I proceed further?
Yes,
Please
sir.
let me know. Okay. Next is the